So permutations versus combinations. Permutations is the one where order matters. Okay, the way I remember this, which is probably counterintuitive, but it may help you, is that if I were going to go to my locker, technically it's not a combination lock, it's a permutation lock because order matters on a locker. It does not matter when I'm looking at like who shows up, right? If Bobby shows up and Judy shows up and Tina shows up, I don't care when they showed up, just so long as they showed up. So be careful. Permutations, order matters. Combinations, order does not matter. So when I'm doing these 1, 2 is a totally different output than 2, 1. So watch out for those. So here's an example of a permutation. 5 books on a shelf, all different. How many ways can they go on the shelf? Well, that's just 5 factorial because it's 5. I've used 1, that makes 4, used 1, 3, used 1, 2, and then there's 1 left over, 120. So we can call this n factorial, n all the way down to 1. So let's say I want to do a subset of the books. I only want to look at 3 books on the shelf. Well, my first option or placement has 5 books. Then I've used 1. Now there's 4 options, and then there's 3 options, giving us a combination of 60. So this isn't just 5 times 4 times 3 times 2 times 1 because 2 of our options, our placements, are no longer applicable. So we are only looking at the first 3 terms here. Notationally, there's a really special way that we want to look at these. If I say n and r, when I'm talking about either permutations or combinations, n is the total sample number, r is how many we're going to choose. So in the last example, we were looking at 5p3 because there's 5 total possibilities, and we're only looking at choosing 3 of those at any one time. So this can be written as npr or NPR. A lot of calculators write it like this, or P with sort of a vector notation here with N over R, or sometimes it's written as P and then NR. So of course, math being the tricker that it is, has got lots of different ways to write the same thing. So the rule, remember the rule is a great tool, but always rely on your understanding and then put it in the tool when we need it. N factorial over n minus r factorial, where n is greater than r, because if this were 0 here, 0 factorial, kind of a weird note, is 1. So do not forget that. It's like the 3 to the 0 thing is 1. It's another one of those. 0 factorial is 1. So you can use the multiplication rule here, or you can use the permutation rule, but we're going to practice using the permutation rule. So if 50 people are running a race, how many ways can first, second, and third occur? Well, you could do it 2 ways. You could say there's 50 people, 49 people, 48 people, or this is going to give us the same thing. P, where it's 50, choose 3. So I have 50 factorial over 50 minus 3 factorial. We need to do the subtraction here before we take the factorial. And so 50 factorial over 47 factorial. 50 minus 3 is 47, hence 47 factorial. Now if I start multiplying these out, I'm going to say 50 times 49 times 48 times 47 times ... all the way down to 1. 47, 46, 45, ... all the way down to 1. Well, each one of these terms in the denominator, 47, is going to pair with a 47 here, creating a 1 to eliminate. 46 will pair with another 46, all the way down. So if I have something like 47 factorial times 50 times 49 times 48 over 47 factorial, then this term and this term are equivalent. They are 1. So I can say that 47 factorial over 47 factorial is simply a 1, and I'm left with exactly the same thing I had here, 50 times 49 times 48. And then you guys can do the multiplication. You know how to multiply. All right, combinations. Again, unorder, or in other words, order does not matter. Big idea, does not matter. Okay, so we're going to talk about horse racing because I like horse racing, and so we're going to look at two different options. I'm going to teach you how to be a gambler. Just kidding. So you can bet for first and second in exact order, right? I'm going to bet that Bobby the Foxhound or whatever, that horse comes in first, and Tina the rugby star, that's the other horse, come in that order, whatever his first name was, and then Tina. Or there is this, which is referred to as a quinella, where I'm saying I think these two horses are going to come in first and second. I'm just not sure which one it's going to be. So obviously, I don't know, maybe it's not obvious to you. This one pays out better because you have to be more specific in your bet. This one pays out not as well because you kind of had some room for error. Combination, permutation, exacta. So if there are 10 horses running, how many types of exacta bets could there be? What about quinella? So we're going to look through that. So in exacta, there are 10 different horses that can come into first, and if one of them comes in first, they can't come in second. So that means there's 9 remaining to come in second place, which is simply a permutation of 10, choose 2. So 9 times 10 gives us 90. All right. Here is kind of a table to help us think about what a quinella is. We're going to think about where these would come from. So I have horses A through J, or 1 through 10. It doesn't matter how you list them. And then I have horses A through J, right? A can't come in first and second, so everything along the diagonal here is irrelevant because you can't have H followed by H. Now, what happens if this represents first place and this represents second place? Well, then B can be followed by A, C can be followed by A, D can be followed by A, all the way out to this guy can come in first and A can come in second. So that's a whole series of possibilities there. However, if this is a combination, right, we're talking about a quinella where it doesn't matter if A comes in first or B comes in first, so long as A and B are both coming in first and second, then this bet and this bet are the same bet because this is just a repeat of this. It's a combination where the combination is the same between both of these. So everything that lives on this side of the diagonal is going to be a repeat of everything that lives above the diagonal. Okay? So you can see that if this whole table needed to be filled out except for the diagonal, that would be your exacta. But only this half of the table up here are the ones that we want to count as total possibilities for quinella. Way less options. Okay? So a combination, in other words, is what your permutation was with a removal of all of the repeats. Okay? So permutation we knew was this, and then we've got to get rid of all of the duplicates, anything that we didn't want to have in there. So we got to divide this guy out again, right? So that means that when I simplify this formula, combination becomes n factorial over n minus r factorial and another r factorial in the denominator. This is going to make our total possibilities limited down even further, so making a smaller total outcome by making the denominator larger. Okay, so that's kind of a fraction concept we have to think about. The notation for combinations, very similar. You can see C and R in sort of a vectory looking thing, or NCR, generally the way you see it on a calculator looks like this, or N with sort of a superscript, C subscript R, or C and then NR is both a subscript, or NR. How is this different? Think back to what we just did. Okay, this one is just NR. Do you notice there's not a C in front of it? Okay, the reason is that when you see this NR, they want you to infer that we are talking about a combination. Without the letter in front of it, they want you to make the assumption that it's a combination, not a permutation. So be really careful. There's an inference to be made. No C equals combination. If there's a P, then it's a permutation. They may choose to put the C in front of it, but they may not. But these two things are the same. Okay? Whenever I see this, I need to think combo rule or formula. Let's go back to our quinella. We had 10 factorial horses that could come in. R factorial is the number that we chose, so 2. And then 10 minus 2 gives us 8 factorial here. So 10 times 9 times 8 factorial over 2 factorial. Well, 2 factorial is just 2 times 1, so 2. And then there's our 8 factorial. These are going to become a 1, so I simply have 5 and a 1, giving us 5 times 9 is 45. Which, if you wanted to, you could go back to your table and count them up if you wanted to. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 8, 7, 6, 5, 4, 3, 2, 1. So it's a summation from 9 to 1. Checks out. See you Monday.